Hello, my name is Meagan Craddock. This is my exam 4-2C video. I will be teaching you about the developmental pathway and the individual genes that lead to the formation of spikes in certain cells of the ectoderm of the spiny beetle. The formation of spikes on the spiny beetle is influenced by these 5 different genes. Each gene either activates or represses the next gene. When speaking in terms of the genes, S activates P activates I represses K represses E, and E activates the formation of spikes within the cells. I will be using a hypothetical story of a wedding to explain the pathway, with each letter representing a person. S is the ex-girlfriend's mom, P is the groom's mom, I is the best man, K is the ex-girlfriend, and E is the groom. You can see each gene's respective roles underneath it on the screen. So in the wedding scenario, the ex-girlfriend's mom finds out about her daughter's plans to crash the wedding, so she warns the groom's mom, who she is friends with from work. The groom's mom warns the best man, who is able to stop the ex-girlfriend from objecting to the vows. With no interruption by the ex-girlfriend, the wedding proceeds as planned, and the lovely couple are wed. In this pathway, the P gene is mutated and cannot function properly. So, the groom's mom doesn't pick up her phone. So she isn't aware of the ex-girlfriend's plans and therefore can't warn the best man. The best man then can't stop the ex-girlfriend from objecting to the wedding, and the groom, who never got over his ex, leaves his soon-to-be wife at the altar to go back to his ex, and the wedding is canceled. In this pathway, I is mutated. So despite the ex-girlfriend's mom and the groom's mom's best efforts, the best man is sick the day of the wedding and therefore can't stop the ex-girlfriend from objecting to the wedding. The same thing happens here as in the last scenario. The groom left his soon-to-be wife at the altar and went back to his ex-girlfriend, effectively canceling the wedding. In this pathway, both I and E are mutated. Like in the last example, the best man is sick and can't stop the ex-girlfriend from crashing the wedding, but that doesn't matter because the groom didn't bother to show up anyway, and without the groom, there could be no wedding. Here, S and K are mutated. In this final situation, the ex-girlfriend's mom was able to convince the ex-girlfriend that crashing the wedding wasn't the best idea, it would only lead to heartbreak. The ex-girlfriend's mom never needed to warn the groom's mom, and the best man didn't have to stop the ex-girlfriend. And with no ex-girlfriend to object to the wedding, the groom has no reason to leave his soon-to-be wife at the altar, and the wedding proceeds. So why don't all cells on the ectoderm have spikes? My theory is because forming the spikes takes energy, and the beetle wants to conserve energy wherever it can. Producing fewer spikes not only conserves energy at the molecular level, but it also prevents the beetle from being overwhelmed by the sheer amount of spikes on its body and the weight that comes along with it. The beetle's body weighs less, so it takes less energy for it to move, but it still has enough spikes on it to protect itself, while not being completely covered by them. And these are my references.